Yes, all right. Number 5, if you have a to the power 1 over n. All right, pay very attentive here. A to the power 1 over n. From this power, we have a fraction, and 1 is the numerator, the n here is the denominator. Now, the denominator is going to form a root, which is an nth root of what the base is. Whereas this numerator is going to raise the base to a power of what it is, so that a to the power 1 is still the same thing with what a. So we're going to leave it like that. This is what we have as the rule number 5. Example to this is if you have 1 to 5, simplify 1 to 5 all to the power 1 over 3. What is this going to be? Look at this. 1 to 5 becomes the base, and 1 over n becomes 1 over what? 3. So 3 is representing the n. Since the n is to be nth root of what the base is, I'm going to have the third root of what? Third root of 2 of 1 to 5. All right. And now the power, the numerator is going to raise the base to a what? Whatever it is. So 1 to 5 raised to power 1 is still 1 to 5. So I'm going to leave it like that. Now going furthermore, third root of 1 to 5, third root of any number means the number you're going to bring together 3 times and multiply it with each other is going to give us what is under the root. So what number will multiply itself 3 times that will give us 1 to 5? Let's check. This should be equals to 5 multiplied by 5 multiplied by 5. So that 5 multiplied by 5 is 25. 25 multiplied by 5, we count in 25. 25, 50, 55, sorry, 75, 100, 125. So this is what we have, so that the third root of 1 to 5 is 5 multiplied by 5 multiplied by 5. Since 5 is that third root, is going to be equals what? 5. Normally, I'm not going to put it as root of 5 multiplied by 5 multiplied by 5. It's just because it's a lecture class. I'm just going to put it at what? 5. That's the answer. Now, another example, if we have 64 to the power 1 over 2. Now, 64 to the power 1 over 2 is still the same thing here, whereby the 64 is the base, so that I'm going to have the new denominator of the fraction index is going to be the root of what? 64. Now, because the denominator is 2, I have 2 root 64. But 2 root 64 is the same thing with what? Root 64. Root means 2. All right. But since we have 3 here, it means that the root is representing what? 3. So what is the root of 64? All to the power 1, which is still going to give us the same thing. So we exclude what? That 1. So root 64 means something you're going to bring 2 times, because we have it to be what? 2, which is the same thing with what? Root. 2 number that will give us 65 is going to be equals what? 8 multiplied by 8. So when 8 comes together, it will give us 64, and this is equals what? 8, because 8 is the root what? 64. Remember, I will not put this in this form just because it's a teaching class. I'm going to put it as what? 8. Now, going over to the 6th rule of indices. Now, 6th rule of indices is the same thing with this, but in this case, the numerator of the index fraction is not going to be 1. It is not going to be a to the power m over what? N. So we're not going to like leave the 1 which we don't use to put here. All right, you're going to include it because it's no longer going to be 1 again, but it's going to be a number greater than 1. And once we have it, you're going to do it as equals to the denominator will also form the nth root of whatever the base is. And now, since we have this to be more than 1, we are also going to raise it to the power of whatever the base is. So this is equals this. This is also equals to, either you do it in this form or you do it as the nth root of a, now all to the power m, which is a what? Numerator. All right. Either you do it this way or you also make it to be in this form, just a single root, and then you have a to the power m multiplied by 1. Sorry, multiplied by n, which is a what? New denominator. So this equals this, equals this, equals this. When you have an expression in this form, it's either you use this, or you use this, or you use what? This. Example. Let's say we asked to simplify. Let's say we asked to simplify 81 to the power 3 over 4. Simplifying 81 to the power 3 over 4. How will you tackle it? Look at this is the same thing with this. Now the power which is a fraction is the same thing with fraction. Now because this the numerator of the fraction is not 1, so it's referred to what this expression. So I'm going to have these to be equals. 81 is going to be there, but this 81 is now going to be under the root of whatever the denominator is. But the denominator is 4 here, so I'll have to the fourth root of 81. Now, should I use this or use this or use this? I will prefer and I will like you guys to use this particular one over here. It is more easier and simple. All right, so from here, we are going to have all to the power what m, which m here is what we have as what 3. So that fourth root of 81 means number that is going to come 4 good times that will give us 81. And what is that number? That number is what? 3. Because if 3 should multiply by 3, multiply by 3, multiply by 3, 4 times, 3 multiplied by 3 is going to give us 9. 9 multiplied by 3 is going to give us 27. 27 multiplied by 3 is going to give us 81. So fourth root of 81 is what? 3. And it's still to the power what? 3. So 3 to the power 3 is known to be what? 27. This is our answer. Or you can make it to be in this form, or you can make it to be what? In this form. Now going over to the seventh law of indices. The seventh law of indices is talking about power rule. So if I have a base A and it is to the power n and is also to the power m, what I'm going to do here is I'm going to say this is equals to A. Now these powers, I'm going to multiply them so that n will multiply by what? M. The base will multiply by what? What the power is. And this is what will be your answer. Example to this seventh law of indices. So that if we have 2 to the power 3 or to the power 2. So how can you simplify this? This is going to be equals 2 to the power 3 to the power 2. I'm going to say 2 is to the power 3 multiplied by what? 2. The base, the powers, you're going to multiply them. Okay? So that 3 multiplied by 2 is going to give us what? 2 to the power 6. You can leave your answer here, or you can go on the way to say 2 multiplied by 2 multiplied by 2 and find whatever the value is. But we are going to stop here because of time. Now, we are looking at the 8th law of indices. The 8 laws of indices. The 8 laws of indices to this 11th law of indices, we are going to talk about distribution power of distribution. Now, if I have A over B to the power n, if you have a fraction to the power n, this power is distributive. This is equals to what? A to the power n all over B to the power n. Okay, is distributive to whatever the fractions are. All right, now the 9th law of indices say that if I have A multiplied by B all to the power n, when they are multiplying and they are all to the power n or to the power of any number, this power is distributive in the bracket because we have a multiplication, so that it is now going to be equals to A to the power n multiplied by B to the power n. What happens is that I use this A raised to power n, use this B raised to power n, is the same thing. Now rule number 10 is if I have A plus B all to the power n, this is not equals to, it is not equals to A to the power n plus B to the power n. So this, if you say that this is equals this, it is wrong. It's going to give you a wrong answer. All you need to do is to add this together. Assuming it is what 3 and 2 to the power n, so the power 2 is going to be 3 plus 3, 3 plus 2 is 5 to the power what 2, which is what 25. So once it is under addition, the power are now distributive. Now the 11th rule. 11th rule says that if I have A minus B all to the power n, this is also not equals to A to the power n minus B to the power n. If you do it like this, you're going to fail. So it is not equals to what? This.